Hello everyone, today we're going to be looking at volume, and let's start this off by looking at some atoms. So here we have a diagram of some atoms. In particular, these are marshmallow atoms. So we know from discussing mass, atoms are these small little particles, too tiny to see, and they're made of matter. So all the stuff in there is matter. And now imagine we take this matter and you put it in the palm of your hand. So you've got a marshmallow in the palm of your hand, and you squeeze it. You apply a force from all sides. You can imagine what happens to the marshmallow. It shrinks. So now we have a marshmallow that has the same mass. Remember, mass is a measure of how much matter is in the object, how much stuff makes up the atoms. Notice that the amount of matter didn't change. We saw 9 atoms before. We still have those same 9 atoms, and they didn't change size. Our mass is exactly the same, but that mass takes up less space. So we need a way to talk about that quantity of how much space is taken up, and we call that volume. Volume is the amount of space taken up by the atoms of an object. And really that space comes from the space in between the atoms. So if there's a lot of space in between the atoms of a substance, it's going to have a greater volume. A smaller space will mean a smaller volume. Let's talk about how to measure this. If we're going to calculate the volume of a regular solid, say this cube, there are different formulas we can use. So we can use the volume of a cube, volume of a sphere, and you can look those equations up. We're going to talk about a cube first just because it's pretty straightforward. So first, all we have to do is measure the sides. So we can take a ruler and measure the sides of this. 4 centimeters by 4 centimeters by 4 centimeters. We know from years and years of math that to find the volume of this, we take length times width times height. So replacing length, width, and height with their numbers, we see that the volume is 4 centimeters times 4 centimeters times 4 centimeters. Now in order to do this calculation, we have to worry about both the number and the units. So the units in this case are those centimeters. Multiplying the number is easy enough. 4 times 4 times 4, that's 4 cubed, or 64. So the volume will be 64 something. We have to look at the units to this. Anytime we take units and we multiply them, so centimeters times centimeters times centimeters, that's just another way of saying centimeters cubed. We multiply those units just like we multiply the numbers. So our result is that the volume of the cube is 64 cubic centimeters. Now this unit kind of makes sense for volume. A cubic centimeter you can imagine as just being a cube that's 1 centimeter by 1 centimeter by 1 centimeter. And we're basically saying how many of those 1 centimeter cubes could fit inside this cube. And we could get 64 of those in there. So again, cubic centimeters are units of volume. Now let's talk about how to measure the volume of a liquid. For this, we're going to use a piece of equipment called a graduated cylinder, which you see in this picture. And each one of these markings on this, I didn't get the units off of there, they're written at the top, but each one of these marks a milliliter. So you can think of liters, everybody remembers this most easily from a 2-liter bottle of soda. Same idea with the liters, except now we're talking about milliliters, so much smaller than that. But milliliters are the markings here, so that's 2 milliliters, 3 milliliters, 4 milliliters, etc. And the thing you have to remember is that cubic centimeters and milliliters are exactly the same. So 1 milliliter is the same as 1 cubic centimeter, which comes in pretty handy. So let's talk about how to read the volume off of this. If we look closely, and in fact when you read the volume of a liquid from a graduated cylinder, you have to get your eyes right on level with where the water is. So you have to be looking straight at it. And when you do, you'll notice this curve in the bottom. Now that's colored red because it's reflecting the red base of this. Don't let that throw you off. That is just water. But you can see this curve in the water, which we call a meniscus. And anytime you read from the very bottom of the meniscus. So in this case, I would say that this is 3, 3.1, 3.2, somewhere about 3.27 or 3.28 milliliters. But again, you have to be on eye level and make sure you pay attention to units. Lastly, let's talk about measuring the volume of an irregular solid. So this would be something that you can't use a volume formula to calculate it. It's not like a cube or a sphere or a cylinder or something like that. Say like a rock would be a good example of something that you might have to calculate the volume or find the volume of. The way you do this is actually still using a graduated cylinder. You'll fill the cylinder less than halfway with water and measure the volume of the water. You'll then drop the rock in, or whatever you're trying to measure the volume of, and you'll notice that the volume will increase. The difference between the volume of the water and the volume of the water and whatever irregular object is in there will be the volume of that irregular object.